Hi and welcome to this SOLIDWORKS tutorial for a set of measuring spoons. These spoons have been designed to the milliliter measurements, but are also represented in teaspoon and tablespoon measurements. In this tutorial I will demonstrate how the mass tool can be used to show the volume of the spoons. I will also show the outward shell tool and utilise the sketch tool to add the measurement details to the spoon handles. When the parts are all complete, I will show you how I assembled the parts to produce an exploded view to create an animation. To begin, start a new part. The first bit of information I needed to create the spoons was the radii of the inner spoon scoop. The shape of the inner spoon is a hemisphere, so to work out the radii needed to create the correct volume, I used a hemisphere volume calculator. By inputting the volume of the teaspoon as 15 cubic millimeters, which is equal to 15 millilitres, it gives me a radius of 19.276. If you would like to see how I work out the radii based on volume without a generator, please visit the blog where I show my calculations. So, sketching onto the front plane, take the line tool, start from this axis and go out vertically. Hover over the end point of the line to create an arc level with the axis like this and join it up. Selecting both lines, add an equal relation to them. Then add a smart dimension here. For the tablespoon, the radius is 19.276. I am using the rounded up versions of the radii for a simple input, so the volumes will not be exact but close enough for the spoon's purpose. Revolve the profile along this edge to create the inner volume of the spoon. You can check the mass properties of the spoon using Evaluate, then Mass Properties. The number I'm looking for is under Volume. Here we have 15,000.63 cubic millimeters, which is equal to 15 cubic centimeters or 15 milliliters, so this is what I'm after. If I go back into the sketch and input the exact number for the radii here to 8 decimal places, which is 19.27573210, when I check the mass properties, I will get the exact volume, but to save time, I'm going to use the rounded up values. Now that I have the right volume for the spoon, it's time to create the spoon itself. To do this, I can use the shell tool. Selecting shell under features, change the shell thickness to 1 mil and select the top face of the revolve. Ensure you then check shell outward here and OK the feature. This creates a 1 mil wall on the outside of the revolve, and the revolve body becomes the spoon's scoop. For the handle, start a new sketch onto the top face of the spoon. Selecting the inner edge of the spoon, convert the entities. Take the centre line and go from the inner point here of the circle sketch and draw a 55mm horizontal line. Then take the line tool and sketch from the circle edge above the line, go horizontally above the centre line, and then draw an arc at the end of the centre line, going to the other side, level with the other line, and join it back up to the circle, ensuring that the line is horizontal. Now, to define the sketch, start with some relations. Select the centre point of the arc and the centre line and add a coincident relation. Next, select the arc and at the end point of the centre line here, add a midpoint relation. Then take smart dimensions and add a dimension to the centre line. Make this 55mm. Then add another between these two lines. This should be 10mm. Trim away the excess circle here. With the sketch fully defined, add a circle to the centre point of the arc. This should be 4mm in diameter. This will be used to add the spoon to a metal ring. Extrude the sketch by 2mm. You will need to flip the direction to look like this and OK the feature. To make the spoon shape a little bit more interesting, I'm going to fillet this edge here by 20mm and the one on the other side. Then I'm going to add a small fillet along this edge, changing the fillet dimension to 0.2mm and selecting the edges of the hole and the bottom edge of the handle. For the spoon's measurements, start a new sketch on the top face of the spoon handle. I need to add some guides for the measurement text. Use the centre line and draw a 6mm line down from the outer arc edge. and then horizontally by 25mm. Ensure you fully define this. Selecting the text tool, I need to select a guide curve for my text. Select this line, then in the text box type in 1 tablespoon or 1 TBS. Leave 3 spaces and then type in 15mm. Right now the text is in the wrong place, so use these icons to flip the text above the line and backwards like this. To change the font size, untick Use Document Font, then select Font. Here you can change the font style and height. For this I'm changing the height to 2mm and making the font bold. The only issue I have now is that the text is not centered to the line. To fix this, you can add spaces to the end of the text in the text box. Here I've added 7 spaces to center my text where I want it. Use Cut Extrude to cut the sketch by 0.2mm into the spoon handle. With the first spoon done, save the part with the spoon size and keep the part open. I can now use this part to create the other 4 spoons. To do this, roll back the features up to the revolve. For half a tablespoon or 7.5ml, change the radius to 15.3mm and OK the feature. You can double check the volume of the spoon with mass properties. It should be very close to 7,500 cubic millimeters like this. It's okay to be slightly off, as it wouldn't really affect the spoons. But as I mentioned with the last spoon, if you input the exact radii to 8 decimal places, you will get the exact volume. All of these are available on the blog if you wish to use them. Now roll back the features up to the handle boss extrusion and edit the sketch. Each handle length will need to increase as the spoons get larger so that they sit into each other and that the handle holes all line up. For this spoon, change the handle length to 58mm and OK the feature. Finally, roll back the features to the bottom and edit the Cut Extrude sketch. Clicking onto the text to edit, select back into the text box and change the spoon size to half a tablespoon and 7.5ml. You can then OK the feature. You need to use Save As to save the new spoon with another name. Keeping the part open still, repeat the same process as before and change the revolve radius to 13.365mm. Check the volume of the revolve before moving on. It should be close to 5,000 cubic millimeters. The handle length for this spoon should be 59.5mm. And finally, amend the text on the handle to 1 teaspoon and 5ml. Use Save As to save the new spoon. For the next spoon, the half teaspoon, change the radius to 10.608mm. The volume should be around 2,500 cubic millimeters. The handle length for this spoon is 61mm. Next, amend the text on the handle. This should be half a teaspoon and 2.5mm. Again, don't forget to use Save As to save the new part with the spoon size for the name. For the final spoon, the 1/4 teaspoon, change the radius to 8.42mm and OK the feature. The volume of the revolve should be around 1,250 cubic millimeters. The handle length should be 62mm. Finally, change the text on the handle to read 1/4 teaspoon and 1.25ml. Now, save the final spoon with Save As You can then close the part ready to create the ring to hold all the spoons together. Starting a new part, begin a new sketch onto the front plane. Take the line tool and sketching above the axis, draw a vertical line up, a horizontal line out, and then create an arc with the line going below the axis like this, and end it level with the start of the arc. Draw a horizontal line across and level to the axis, and then go up near to the axis but not on it. To define this, I'm going to start with relations. Make these two lines equal. Then, selecting the centre point of the arc and the axis, make these horizontal to each other. For the dimensions, add a dimension to the top and bottom line. This should be 35mm. This line should be 17mm. And from this edge to this point, the width should be 6mm. With the sketch fully defined, fill in the corner points by 5mm each. You can just check yes when the warning appears. The sketch will remain fully defined. From here, I can select the sweep feature. I want to create a circular sweep. I don't need to draw the profile for this. I can just select circular profile here. Select the sweep path and change the circle diameter to 1.5mm and OK the feature. Save the part as ring. With the part open, go to File and make assembly from part. Check the green tick to drop the ring part. This is now a fixed part. Use Insert Components to bring in the measuring spoons. Select the pin here to keep the components list open. That way you can drop in the spoons in order of size, which makes it easier to make them. Place the spoons into the assembly near the ring largest spoon first. With all the spoons in, close Insert Components. Now to make all the components into position, select one of the whole edges of the first spoon and select the mate icon. Make the spoon concentric to the ring like this and lock its rotation. Repeat for the next spoon, remembering to lock the rotation. Next, mate the underface of the spoon's handles to the top face of the handle below, coinciding to each other. Repeat this process for the other spoons in order until they are all attached to the ring and sat inside of each other. Also ensure that the spoons are towards the bottom of the ring to look like this. I mated them all this way to keep all the parts together before I begin an exploded view of the spoons. Selecting the Configurations tab, right-click on the default configuration and New Exploded View. Selecting the top spoon, drag the spoon up along the y-axis using the triad arrows. Edit the height of this movement here to 18.5mm. Ensure that the spoon does not overlap the ring corner and select Done. If it does, you need to move the spoons lower before creating the exploded view. The next step is to rotate the spoon on the ring. Selecting into the axis box here, I need to change the location of the rotation perimeters. Make temporary axes visible and select the ring's visible axis here. Before I can rotate, I must change the distance dimension to 0 so that the spoon remains in place by the axis and only rotates. For the rotation angle, change this to -120 degrees and select Add Step. With the first spoon in position, I can repeat the process for the next 3 spoons. Each one must move up by 18.5mm, but for the rotation, the next spoon must rotate -95 degrees. The third spoon must rotate -65 degrees, and the fourth spoon by -35 degrees. Ensure you move the last spoon up by 18.5mm too, but this does not need rotating. With all the steps in place, OK the explode. The spoons should look like this in their exploded state. You can right-click and animate the collapse of the spoons to see the spoons go back into their original position like this. I used the exploded view to create an exploded animation in Motion Study. This could then be edited and rendered using SOLIDWORKS Visualize. I hope you enjoyed this tutorial. Thank you for watching.